if you try and create a disembodied super intelligence, there's a fierce argument raging now as to whether or not you can do it with LLMs. The theory that we followed was that if you're going to make a robot which maybe can't solve what's known as the hard problem, we can at least have simulated feelings or simulated reactions to situations, then its interaction should be qualitatively similar to that of a real person. So I was asked to build a robot which had the same physical structure.
How long does it took to put this together?
About 1.5 years, I guess. Maybe 2.
Thanks, Rob, for taking the time. And especially thank you for setting up the camera in the lab, because that gives us the opportunity to see what you're working on. I can't remember the first time we talked to each other, but I think it was after a video of your hand went kind of viral on my account on LinkedIn.
Yes, that's the V1 Dex hand, and you can build that for about $300 US dollars worth of components. $300 of components, assuming you have your own 3D printer.
And I think we got in touch there. Yes, there it is. It looks beautiful.
Thank you very much. This is in fact the old one. So this was printed on my machine, and I'm trying to get through the build guide for the new one, and that's printed with actually it's the same model. But I never filmed it the first time I made it, so I'm trying to teach people how to make it. It's not as easy as I thought.
I mean, you do have your own YouTube channel, quite successful. I think the last time I had a look at it was 15K, because we talked a few times, Rob, and maybe you can give us a few insights in where you come from, maybe a little bit of your backstory, and what you're working at the moment. That would be very interesting.
I went to university twice, in fact. So the first time was to Cambridge University, where I studied engineering. And I ended up doing a TV show called Robot Wars when I was an undergraduate. And through that, I met a guy at workshops called Arthur Chilcott.
Mortis 3, back to the 3rd series. And apart from the chassis, we've basically redone everything. It's got new batteries, it's got new electronics, it's got new motors. It's got filtered air supply, it's got a new weapon. The axle is still the same, but it goes about twice as fast now. The lifter will lift Arthur quite comfortably. It's all titanium.
And Arthur is, I guess you call him an old school technician. He knew how to make anything. He made the core drills, which drilled out the Antarctic ice samples. So he had a huge range of knowledge on how you actually make stuff. And I always feel that was kind of a crucial extra bit, because obviously at university you get a very good education. Hopefully Cambridge you get a very good one, but it's going to be technical. And there's a big difference between the theory and actually making something work. So I kind of got both there. And there was this idea that perhaps the TV shows would actually make some money. So I did that for quite a long time, but in the end, it didn't, and I suspect they still actually haven't. And then, so eventually, I went through a series of experiments, just outright failures where I tried to get things to work. Eventually, the TV show also collapsed. That never became a commercial thing. And then that's when I went back to university for the second time, and I did a master's in embedded systems and robotics at the University of Essex. And whilst I was, I guess a postgrad, you'd call me, but it was just, postgrad. We built the world's first commercially displayed robot fish for the London Aquarium. The other thing that happened at University of Essex is I met Professor Owen Holland, and he was developing theories of consciousness. One of them went along the lines that you require qualitatively similar physical interactions with the environment of an embedded intelligence in order to produce anything which is going to be like a human consciousness. So, mind and body. If you're going to try and make something which has a human-like aspect to its consciousness, but you need to give it a human-like body.
How can you explain this in a way I will be able to understand this?
Well, let me show you the robots. If you try and create a disembodied super intelligence, then you end up with a very brittle kind of intelligence. So the intelligence that you see in a space odyssey is not really, well, we used to think that there was no possibility of that achieving any kind of true intelligence. And obviously there's a fierce argument raging now as to whether or not you can do it with LLMs. But the theory that we followed was that if you're going to make a robot which maybe can't solve what's known as the hard problem.
The hard problem is, how does the brain give you consciousness?
Can at least have simulated feelings or simulated reactions to situations, then its interaction should be qualitatively similar to that of a real person. So I was asked to build a robot which had the same physical structure.
How long does it took to put this together?
Ooh. Hard to say. About 1.5 years, I guess. Maybe 2. But there was an earlier prototype as well.
So this is the torso and parts of the head and one arm or 2 arms? Looks like 2 arms.
There's 2 arms, yeah.
All right.
So in many ways, this is the most anatomically complete because it has the most, I guess, the most degrees of freedom. Got those 2 forearm bones there, which we had a mathematician in the group, Veliko Botkonyak, and he was horrified by the design of this thing in terms of trying to model it. I mean, you can see the shoulder dislocated. So that is what's known as the glenoid socket. And that, if I put it back in, that's the shoulder ball, that thing there. And if you dislocate your shoulder, that's what happens.
Let's not do that.
That completely, it goes like that. This one has shoulder blades. So this one has collarbones, shoulder blades. So as far as I know, this is the most anatomically accurate robot.
So how many people in total worked on that model?
Just me.
Just yourself? Crazy. And so when was the last time that you actually moved it?
Very long time. This one actually, I suspect, would still go fairly easily because it's relatively simple. The issue is that everything is outdated on it. So I may have the debugging tool somewhere, but there's a reasonable chance that if I switch it all on, and I could get the interface working, this one would actually move. There was a few that came later. I don't have them all anymore. This one's got probably the most complete because it's got the legs as well. But it was never mechanically strong enough to walk. It could just stand up, and you see it's got a pole there which supports it.
Will you ever be able to put some other hardware, some surface on it? Because right now we can see through the robot, right? So if we're talking about humanoids, we are always thinking about something that looks very similar, but mostly covered in metal. Some freakish things I've seen with like silicon or other materials that are replacing or mimicking the human skin. Did you ever thought about putting something above it?
Oh, no, of course. I've considered that for a very long time. I've always thought that it's going to be one of the hardest things to get right, and that it's not really that necessary at the moment. I'm interested in making a very general purpose power tool. Essentially, is how I think of it. So how it looks is important in the sense that it will affect the relationship which people inherently have with the system, with the robot. But I don't believe in trying to make it look very realistic.
Yeah, I'm against that as well, but some people are really looking forward to that one. I mean, this year or last year, actually, 2023, was such a big breakthrough for humanoid robot companies. We have a few now that are showing. I mean, I think the last one was Figure from Brad Addock. That is the US company. Machine. Yes. and Sanctuary from Vancouver. Here we go. Thank you. Electronic in Texas. Oh yeah, agility. And clone. And then we have here in Europe, we have Eve from V1 so the Norway company.
So I like Eve because it has wheels.
Mm.
Yes, and so mine will have wheels, and so this is reassuring that that's acceptable. It kind of just leans immediately into the debate about whether or not they really have to walk, and I think that really having them walk is not a good idea, actually.
You don't think it's a good idea? Why is that?
Not generally. I think specialized ones, you're going to want them to have legs.
Wife-Like Enterprises is a company that sells robot wives, especially tailored for each client.
But in terms of a general purpose robot, which is just going to do a lot of things as economically as possible, I think putting legs on it is an enormous red herring. It makes everything else harder and more expensive. And that just seems generally not a good idea.
I mean, especially from people that are coming out of manufacturing, they're asking the question, why humanoid in the first place? Because there's a lot of robots that are doing specific tasks in the factory that are much more efficient than a human, right? They work faster and more reliable and longer. So why human being?
I think you can get there from first principles, but the argument as to why you need them is if you look at a manufacturing system now and you use the best manufacturing technology available, then you still need people. We never reached the lights out factory, and we've certainly never reached the lights out factory for a very flexible style of manufacturing. So these were the kind of the manufacturing dreams when I was at university, but it just hasn't happened. You still need people in there. So the next thing that you can do is make those people be able to service a much greater number of machines. And what the machines have to do is copy what the person was doing, then that's why you need a humanoid form factor, at least in the bit which is typically the hands and seeing stuff. And then that's what you need to copy that.
Yeah, I mean, there's a bunch of people that's saying it will take a much longer than some of the company owners, CEOs pushing out there, because we just saw I think there was a new video last week from the Tesla bot. I think that was pretty neat. And yeah, if you look through the forums, if you talk to people in the industry, everyone is very skeptical about the real advantage that came out of it, and the real progress that happened. In the very end, we will see how long it actually will take. I mean, I think level 5 autonomous driving is proclaimed by Elon Musk since 2016 or 17. So we still haven't reached that yet.
That's clearly untrue. So if you're going to start using that as no one's done level 5.
Right? Yeah. So it might take a little bit longer.
The problem is if you start bringing in Tesla and the way that it's being used so blatantly as a marketing and a distraction tool, then that to me is muddying the waters. It's very impressive what they've done in the time they've had. I think it's moved the conversation on a lot in terms of the general perception. But I take it to a point of a much more fundamental look at how technologies have always emerged, which is that right up until they come out, it is the sensible thing to expect that they're not going to happen. So we're all kind of going to be surprised when it finally does. But even in the way that you're talking and trying to take a kind of more skeptical line, it's clear that in your mind it's going to happen now. Is that reasonable?
I mean, these like surprises, like a revelation or like a premiere with a product that is working in a way we haven't expected before, didn't happen too often, right? So very often you have an incremental improvement over time of things, right?
These are the big shifts, like horses to cars. But there's lots of quotes about people saying horses will last forever. And Mr. Henry Ford is completely mad, right? And there's lots of quotes just before the Wright brothers first flew. Heavier than air flight is impossible. Commercial air is impossible. And it happens quickly. Same with the iPhone. iPhones are pointless and stupid. It's never going to happen. The internet's just ridiculous. It's never going to happen.
I don't agree. I think the internet, I don't think we've even seen the tip of the iceberg. I think the potential of what the internet is going to do to society, both good and bad, is unimaginable. I think we're actually on the cusp of something exhilarating and terrifying.
It's just a tool, though, isn't it?
No, it's not. No, it's an alien life form.
What do you think? I mean, when you think then about the
is
future
there life
of it,
on Mars? Yes, it's just landed here.
But it's simply a different delivery system there. You're arguing about something more profound.
Oh yeah, I'm talking about the actual context, and the state of content is going to be so different to anything that we can really envisage at the moment, where the interplay between the user and the provider will be so in simpatico. It's going to crush our ideas of what mediums are all about. That grey space in the middle is what the 21st century is going to be about.
It's obviously made of increments, but there are big shifts which can occur. And robotics, when it happens, and it does very much seem now that saying when is no longer at all controversial, it will subsume several others. It will subsume IT and computing and lots of things will be subsumed by it. So it should just be absolutely enormous when it finally does.
So, and
but, yeah,
from your point of view, so what is your best guess? So when will this happen? When will we have this iPhone 2007 moment or 8? I can't remember. So when everyone is really stunned by the progress.
Can you take it out here?
Oh my God.
This is the new MacBook Air.
Today we only see videos, right? So there's only videos, but there was no show where you were actually able to see a walking and working humanoid robot. So
around people particularly is the issue. So that to me is really
oh yeah, true.
But for one way that I will really try and distinguish myself, apart from just making it lower cost, is that it will be accessible much earlier. And the reason for that is because I'm not trying to hit a commercial level of release. So this kind of iPhone moment where you can just go and buy it and it works, and you bring it home and you unbox it and you just turn it on, it just does stuff. That I think is still clearly a good distance away, both technologically, but mainly for reasons of reliability, but also culturally and possibly economically as well. But if you look back at the beginning of computers, just thinking Apple, the first Apple computers technically were a bunch of little screens and keyboards and stuff, I think, assembled in the kitchen of one of the founders and then sold through a local, just a local hardware store or a local electronics store. And Microsoft began with, I think, control systems for model rockets. So if you can put the capabilities into enthusiast hands, they take responsibility for it not, going wrong and doing crazy stuff. But then suddenly you've got an active experiment going on, and that essentially is what I'm trying to make happen.
I mean, I think this is the perfect handover to the hand. So, like I said in the early beginning of the episode, that one of the reasons we came together was a clip I took. I can't remember where I found it exactly, and it was a viral moment for my account. People were really eager to see it and to understand how it works. And you just said that on your account you are showing how to put this together, right? Maybe you can tell us a little bit. This is a project that you're working together with Trent. I asked him, and we will hear him in a later episode. Maybe you can tell us a little bit about this hand and what is your idea about this? How came this together, and where are you standing in that journey that you have in mind?
Okie dokie. So the hand, in fact, there's two. So this one was done specifically to coincide with the release of the Jetson Nano, and we have the Jetson logo. You're not allowed to use the NVIDIA logo, but we showed it personally to Jensen Huang, and he didn't tell us we couldn't use it, so it stayed on there. This one is called the Robot Nano Hand, and that was done with a distributor of NVIDIA's called Silicon Highway. So they essentially commissioned me to design this as a marketing tool for the Jetson Nano. And about 2 weeks after we launched it, they cancelled production of the Jetson Nano due to COVID. For almost 2 years, it's back now. So we're going to relaunch this at some point. But since then, this one's also open source. But this one has got a camera smack in the middle of the palm. It's the cable for it. And normally there's a camera here. And this one can just kind of copy hand actions. And it was designed as a hello world where you learn how to build some hardware, and then you have to do the coding on the Jetson. And then when you put them together, you can get it to do stuff. So it's like an entry point into robotics, because robotics is very different to computing now. I guess it's similar to what computing was like right back in the beginning. You couldn't be sure if your program wasn't working because the computer was broken or because your code was wrong. These days, you assume that the machine is a perfect finite state machine, right? You're completely abstracted from the hardware layer, unless you're trying to go faster or you're coming up against the limits of memory and that kind of stuff. But you assume the computer, does what it thinks it's doing and says what it's doing. But in robotics, you can't assume that, because every time it stops working, could be code, could be something, could be electronics, could be broken. So it's a very different proposition to use robots on a daily basis. And then, so having that one launched and just completely bombed, I had a conversation with a guy who was looking at doing a startup, and one of the hands he mentioned to me was called the Flex Hand, which was done by Korea Advanced Institute of Science and Technology. And that had a nice setup of tendons, a nice setup of tendons in the fingers, the way it arranged two on the inside like this one, and then the long one passes almost through the center of this knuckle and just actuates the last two joints.
How many joints do we have here?
So this has got, in terms of passive joints, almost the same as the real human hand. You can spread the knuckles, you can bend the knuckles, and you can flex the fingers in two places. The wrist has got full human range, and it's got yaw, and it rotates from the back here. There's a big bearing in the back end. In terms of powered, it's got 19 servos. So it's got 3 for each finger and 1 extension, and then the thumb has only got 4, and the wrist has only got 3. So there's simplification throughout it. I consider it kind of semi-dexterous, because it can grip things, but it can't change the direction of force that it's applying at the fingertips. So you can kind of hook your fingers around things. This one can't do that. It can grab onto things, but it can't manipulate them very well. And you need at least another 5 or 6 degrees to really do that well. Or you have less fingers. So there's options.
And so you guys have a website, right?
Yes. So in fact, Trent maintains that website now, and that's dexhand.org is where we're trying to gather all the information together. And in many ways, it's really an advertisement, right? It's a lightning rod. You found it, and that was the point. But what I'm going to do next is I'm going to do a whole humanoid, but lower cost and smaller. And really, I'd like to get that down. Component-wise, I'd like to get it down to just a few $1,000 for the whole thing, but still capable, not a toy. This is the real distinction. But there's lots of kind of toy robots out there, but there's if you want to start lifting, say 10 pounds or that kind of region, then you have to go up to an industrial robot. And so suddenly you're looking at tens of thousands of euros, and there's a lot of laws that control how they're used. So the design challenge is to make a low cost yet very mechanically capable humanoid. And that's what I'm planning to do this year.
Have you seen the Aloha mobile videos that just came out last week? And I think they're talking about like the hardware was like 30K.
But the total bill of materials for the whole thing works out at 32,000. And I'd like to get it like a fifth of that, ideally. A tenth to a fifth. I think you could do it really cheaply on just a very simple moving base. A few thousand. If you've got your own 3D printer and you know what you're doing, or rather if you follow instructions, I think you can do it for a few thousand. I'm pretty sure of it now.
Coming back to these, you just said printer, and you just said, yeah, I mean the code, right? If I would go to the website, would I be able to download all necessary information to build that hand myself?
Yes, absolutely. I mean, that's the whole point of the Dex.org website, to gather everything together. So all the demos I've done where it was using again a camera and it was copying actions. And Trent did one where you could link it to ChatGPT, and I'm also going to do an extension using a program called Cynthia, which I've just found, and that's got ChatGPT built in as well. But there's a lot of my theory on this is that there will inevitably come a point when all of the software exists in a relatively easy to access format, and I've just started using another one called Edge Impulse, and that allows you to train arbitrary data in various algorithms and derive control sets from that. And my other experiment this year on the big humanoid, which will be using these arms, which are the big Hope arms, is that I will just try everything I can get to work and start putting it together. Because I think there's an enormous gain factor in the human feedback aspect. If you look at how one of the ways that OpenAI made this huge leaps is they used a lot of human feedback. So if you tell the systems where to learn and where to look, they should get much better at, and that's what you're seeing now. They get much better at a small thing, and they don't yet know how to link all of that together. But if every robot has essentially got a human driver in the beginning that does all that for them and deals with the really difficult stuff like social context.
Yeah, end of day, Fox and Firkin, drinks on me.
Whoa, yeah.
Well, this is our big chance. Happy hour. This is what I meant about putting ourselves out there. Come on, everybody will be there. Please, for me. Isn't this great? Are you comfortable? I said, are you comfortable? Are you? For me?
And maintaining safety in a crowd, and things which the AIs are just really, really going to struggle with for a long time. It also gives ownership to the person that's built it, and they give some some agency, some inherent agency to the machine. And then that's what I'm going to try and do. Get a lot of people to build them and take them around and show them and experiment. And I think if you have, that's a probability game. If you have a lot of people that are trying, are looking in a search area, you're just going to make progress faster. So you give them the tools and get on and build stuff. So the hand is just to say, look, this is serious, right? Start with this. Prove to yourself you can build one of these. And by the time you finish that, you can start on the full humanoid, and then just start getting it to do stuff and see where we end up. That's as far as I can plan.
When we talked earlier, then one of the reasons you would like to do this hand. So this is the first step, and you mentioned earlier on that you would like to build an entire humanoid robot and put it in open source and have people involved in that project and contribute to that project. We talked with Trent. So this is a like a colleague of yours who contributed to it. Sorry,
a partner now, because we're developing the V2, which is the one which came afterwards. This is going to be turned into an industrialized, warranted product, because not everyone wants to build robots, right? I mean, I think it's a brilliant thing to do, and I hope at least there'll be a few thousand, tens of thousands around the world. But, that'd be great. But the vast majority of people just want to, buy something which works. So Trent's much more serious than I am, much more realistic as well. So with him, we're going to. You just buy this off the shelf, or in fact, we're doing a rental model in the beginning. So you just rent it, use it for your experiments.
Do you have a timeline for that?
I think the first ones are going out. We're going to very soon, shall we say? Yeah, very soon.
In this year?
Oh, hell yeah!
All right. And we already talked about having an episode together with Trent as an anniversary for the 10th episode, if I would be able to make it so far. Thanks. If people are really interested in, I will put some links into this episode, and people can get in touch with you, and people can have a look at the Dex hand. And if you said this year will be the year where people can actually buy the newest version of it, I think people would be very, very happy. Well, I hope so. I mean, that is, and you don't have to buy it outright. You can just rent it for a bit, because there's always a lot of capital, and also it's going to evolve a lot. But this is the one which did the challenge where it was spinning the balls round. So that's the other thing I'm trying to make happen. I want to have a world record attempt for some dexterous task, but possibly you saw that video, right, where it can turn the balls. I did. That's like a Chinese meditation thing. I did. So if there are robot companies out there that can get their robot hand to do that, see who can do it the fastest, because it's something easy to time. I remember that link, that video you showed it a few weeks ago. I was trying to include the link as well. And thanks again for taking the time. And I'm looking forward to our combined episode with Trent. And thanks again for taking us within your holy lab. And my crazy world. Yes, and I wish you a nice day. And thanks again. If there's any question, people can reach out to you, correct? Sure. Yeah. I mean, it's great to hear from people. Hear what we're up to. Trying to create a robot movement. Nice. That would be cool. Finally, bring around this open era of robots, which are accessible, so you can understand them and they can get them to do all the things they've dreamt of getting robots to do. It's gonna happen soon. I'm absolutely convinced. How soon, I guess, is that's an active question. But I'm going to try and make it happen as quickly as possible. Yes, I'm pretty sure that you are right, that this will happen very soon. I say thank you and talk to you soon. Very much. Take care. Bye bye. Cheers. Bye bye.